Hello and welcome back to the part 3 of our Quadruped Motion Matching tutorial series. So in our last part we have set this up our motion matching where we can evaluate our chooser, and based on that we can switch between trot, walk and different state like trot, walk and running state. So now in this video we will set up our leaning function so that when we are moving it left right our dog character procedurally adopts that. So we are also missing our camera length changes. So let's just first add that functionality. I'm gonna go to our character blueprint and just give me a sec. Updates. I will create a new function. Update spring arm length. So we will grab our spring arm, camera boom, set target arm length, and we will use finterp to get our target arm length current. The target will be our spring arm length. So we have updated the spring arm length in each function, like we have set up our switch to walk, run and trot function. So each function have different arms length set up. So now we need to add tick. We need to call this function update spring arm length and interrupt from current to the updated target length. Get world delta seconds, and the speed will be 2. And we need to set the arm length when we are in idle state. So when we are in idle state, we will set our target arm length to 200. And now when I hit play, you can notice that when this is the idle state, this is the movement state. I will change the spring arm to slightly right a bit, 30. Yeah. Now when we can see when we are in different state, our camera length also changes. This is done. Now let's add up our additional functionality for our leaning. So before going to set up our leaning functionality, first we need to set up our two important nodes in our motion matching, which is one is the offset root board and second is the steering node. So first of all, I have already explained these nodes in detail in my breakdown motion matching tutorial series. So if you want to learn more about these nodes, you can go and check that out. So first of all, offset root bond. So offset root bond, what this does is offset from our mesh from our capsule completely. And then steering node is what it does. Steering node is then based on our root motion animation, if we are using, or any like forward facing movement animation like this one, forward, walk forward, run forward. So steering node then will try to match the mesh rotation with our capsule rotation. So before going to set this up, let me go into the character blueprint first. So I will set this character movement character rotation rate to -1. And now when I hit play, set this to -1, and you can see when we like rotate, when we give the input, the mesh is also moving with the capsule, like rotating with the capsule. If I debug my capsule rotation by adding an arrow, and you can see the arrow represents our capsule rotation. So the mesh is already like synced with the capsule rotation. So what offset root bond will does is, if I add an offset root bond, let me just see it over here. So I'm gonna set the translation mode. I'm gonna set it expose pin and expose pin. Translation mode, set this translation half-life to 0.2, translation error to 0, and yeah, that is pretty much it. So now when I will set the rotation mode to accumulate and translation mode to interpolate. By the way, I have discussed this node in detail in my breakdown motion matching tutorial series. So now when after adding this node, if I hit play, you will notice that my mesh is not in sync with my capsule. The arrow represents my capsule rotation, and the mesh is you can see that mesh will always face in a forward direction. It is not updating with capsule rotation. So offset root bond is doing this functionality. So now we need to add a steering node on top after this, so that our steering node tries to match with capsule rotation by playing the animation, simple animation like start or root motion animation. So now I'm gonna add a new steering node. Steering node over here. So steering node, first thing we need to do is set this alpha to be active when we are in moving state. So in order to do this, I'm gonna create a new function is moving and return value to be boolean with return value if our locomotion state is not equal to idle, which means we are moving. So alpha will be our bool value and set it to, okay, so this function needs to be a thread safe and also pure, so that it can appear in a details panel is moving. So when we are moving, only then we set this steering to be enabled. And for our trajectory, trajectory orientation, we can grab our trajectory, get trajectory sample at time. Let's say at time of in future 0.3, we want the trajectory facing trajectory orientation. And for the procedural target time, so these are the two important target time. Procedural target time, if you can, so this will try to this will be the time which will take for our mesh to align with capsule rotation when we are playing no root motion, like when we are playing a forward facing movement animations like run forward or jog forward. So when we are playing root motion animation like start 90, start 180, then this animated target times comes in. Animated target, this will try to match with the capsule rotation when we are playing the root motion animation. So by the way, these nodes I've already told you guys, I have covered in detail in my breakdown tutorial series, so you can watch that for detail. So for this tutorial purpose, I'm going to set this procedural target time to 0.3 and animated target time to 0.5. And now when I hit play, you can notice that I am offsetting the mesh from capsule, but tries to align with my capsule using this steering node time procedure. If I set this to 1, you will see it will take much longer to try to align with the capsule. See, it is taking much longer. So I have set it to negative. I have set it to 0.3. So now our steering and offset root bond is done. Now we need to add our leaning on top of it. So in order to add the leaning, I have already, if I go to my animation folder, so we need two poses, like a pose which can be like this for left, and a pose which can be like over right. So by the way, you can make these poses by yourself. You just need to grab your idle animation, like inside a test here. Here's the idle animation, and what you can do is rotate the chest like so, rotate the spine, spine one a bit. Like you just need to create a pose which is more similar like this, and we can use these poses for our leaning. So I already have these two poses, additive at local right and left, which comes with this animation pack, these two. So what you need to do here after that is set this to additive type to mesh space for both of these poses, additive type to mesh space, and we already also have this neutral pose as well. I'm going to also set this additive type to mesh space. So now we need to put all these poses inside a blend space, which I already have over here. So this is a pretty simple 1D blend space. We are blending from neutral to left and right. See, so we will play this blend space, additive blend space on top of our current locomotion to perform a additive leaning. So the additive blend space is done. We can see I have set this up to -1 to +1, and blend time 2.2, and smoothing gap to average. So you can create this blend space. It's pretty simple. Now when I grab this blend space, put it into my animation graph and search for apply mesh space additive. Let's say I will put a1 over here. So now you will notice that when I rotate right, my additive animation plays on top of it, and we can see that there is no foot sliding and our character perform procedural leaning. So now the only thing is remained to calculate our leaning procedurally. So in order to calculate the leaning, what I can do here is we need to so in our update trajectory, what we can do here is grab the future, get trajectory velocity. So what we can do is, so here is my trajectory generation. What I can do is grab my future velocity from trajectory and comparing it with my current velocity to find out which direction are we leaning. So this is our trajectory future velocity in time, like let's say in future 0.2, 1 or 0.2. I'm gonna call it trajectory future velocity, like so. So this is our trajectory future velocity. Now we will compare it with our current velocity, and based on that we will calculate the leaning. Okay, so I'm gonna grab my trajectory future velocity, get my current velocity from my character movement component, which we already have created a reference velocity, make rotation from X delta between these two and split. Now when I hit when I print string, okay, so you can notice when I rotate my mouse right, so you can see the value goes from 1 to -1 when we are walking. Values goes from 1 to -1, and when we are in trot state, values grows from -5 to +5, and when we are running, the values goes from -10 to +10. So we need to use this information and clamp into the -1 and -1, so that because our leaning is using -1 and +1. So if I, let's say, put this information directly inside this leaning, you will see like a sudden snapping. So we don't want that. We want to have a smooth result. So in order to get that, I'm gonna use a new function. I'm gonna call this calculate leaning. So here we have this function, calculate leaning. Just give me a sec. So we have seen that our values goes from -1 to +1 when we are in walk state. Our values goes from -5 to +5 when we are in trot, and similarly goes from -10 to +10 when we are in run state. So we will use this information and use map range clamped. So the clamp will be our, we can use different locomotion states. So if our locomotion state is, if we are in walking state, we can, our range is 1 to -1. When we are trot state, our range is 5 to -5. When we are done, our range is 10 to -10. I'm gonna multiply with -1. This will be our A. Okay, and this value, the positive value, will be our B. For idle, I'm going to set it to 10. For idle, I'm going to set it to 0, sorry. And it will output the -1 to +1. This is the lean amount. Leaning amount. So we also need to interpolate this f interp from current to this velocity, and use a, we will use a thread safe function in order to call this. So we will use a delta second from thread safe, and update speed will be our, I'm going to use similarly a select. So when we are in idle state, we want the blend time to be happen faster, like 6. When we are idle state, the blend time will be 5. When we are in trot, the blend time is 7, and when we are done, the blend time will be, like, let's say 8. So this is our lean amount is set up. We will call this function a thread safe, and we will call this, we will mark this function thread safe and call it from blueprint thread safe update animation, calculate leaning. And now when we print our leaning amount, we can see it goes from -1 to +1 with a smooth value is interpolating. Similarly, it remains is in -1 and +1. Okay, so now we need to put this in our blend space. So fingers crossed, we have set up everything. We have set up the motion matching. Motion matching contains the steering node, steering behavior. After that, we are applying the leaning on top of our current selected pose, and then we are applying offset root bond, and at the end we are adding the pose history. All right, let me just double check all the things. So yeah, one thing is remaining. Inside our pose history, we have not added our bonds which we are added for position history. So remember, we have set up our schema where we have placed for position channel, we have set up these ankle points. So in order to match with the with pose history, which animation, which pose are we previously in, we need to place these bonds over here. I'm gonna add a new search for ankle, 4 ankle points, and our pelvis. Yeah, so root bond recovery time, we also need to set this up. Root bond recovery time, we can set this up to -0.3. Yeah, so if you guys if you want to know what are these values used for, I have already explained in my breakdown motion matching tutorial series. So our pose history node is properly set up. Pose history node is done. Offset root bond, yes, it is also done. Motion trajectory, motion matching, steering node, yeah, it is also done. Now let's hit play and see the end result of it. Leaning amount, why it is always negative? Oh, it is start with positive value. So we need to set it to 0. Where is our function calculate lean? Okay. Just give me a second. -1 to +1, 1. Idle to be 10. Let's say, yeah. So now let's hit play and see the results. All right. So here you can notice that we are in trot state. You can see how offset root bond and steering node affects our overall locomotion. See? And now when we are in running state. And you can also notice that our blending is also working fine after putting the right pose, like set up the pose history node, put these collecting bones for our ankles and pelvis. You can see the blending is also working fine. As compared to our last video, the blending was not perfectly synced. By the way, you can also play around with these interpolation speeds. So if you want your character to be in don't cover in like the circle for turning for this circle, if you want to narrow it down, you can change the interpolation speed as well. But I find these values pretty useful for these speeds. So this is our functional motion matching is done. So I hope you guys like these videos, and let me know your feedback. and any comments would be super useful. So let me know your feedback, and I will see you in the next one. Bye.